Recording in progress.
We were discussing the other day about this exercise. And as I was telling you, we need to be careful with falling objects because even though we're going to be using almost the same formulas, we still need to make a few changes. For example, we have these two formulas already for final velocity that we know already, that we memorize because we are good at memorizing formulas. And take a look. These formulas, we're going to use them here in free fall. Now, the difference is that instead of acceleration, we're going to be using the acceleration due to gravity in Earth, which is on Earth, that is negative 9.81 meters per second squared, because it is an acceleration type is going to be measured in meters per second squared. Okay, so that is something you need to be aware of. Now, so what are we going to do? We're going to replace from the formulas that we know, we're going to replace acceleration by gravity. So in these formulas, I'm going to get rid of acceleration, okay? And instead, I'm going to write gravity. Again, instead of acceleration, gravity. And with this, we already adapted the formula. One other change that we need to do is that instead of displacement in x, of change of position in the horizontal axis, we're going to have a change in position but in the vertical axis. So instead of writing x, we're going to be replacing it by delta y, because now the change in position is going to be a vertical change. So in the formula, the other change that I have to do is replacing delta x by delta y. And here I have the formulas already, ready to be used for free fall. Now in this sample problem, it says Jason hits a volleyball so that it moves with an initial velocity of 6 meters per second straight upward. As I was telling you the other day, when we say upward in physics, upward is a direction, okay? And directions have signs. Because it says upward, we're going to consider 6 meters per second to be a positive velocity. So we can include the sign, as I already did over there. Then it says, if the volleyball starts from 2 meters above the floor, so that is telling you, okay, how everything started. It started at 2 meters above the floor, okay? So when we say above, is also a word that indicates that the value that I'm going to have is going to be positive. Above is a positive thing, okay? Below the floor, in that case, will be a negative value. Below the sea level, above the sea level, below the table, above the table. I mean, those are what we know as reference, okay? So my base reference here is the floor, okay? The floor is going to be my main reference because I'm measuring the position of the volleyball from the floor. So the floor is going to be my reference of position. For example, when we're having classes in your classroom, for example, 10-1 and 10-2, both classrooms are located in the third floor. Okay, the third floor is approximately 6.5 meters above the ground. So in that case, we are going to be located at the position plus 6.5. because we are above the ground. But if, for example, um, if there was an elevator and we have to go underground, underground is going to be a negative position because it's going to be below the ground. So I just want you to understand that part, okay? What the positive and the negative means in free fall. Then it says, how long will it be in the air before it strikes the floor? When I say how long, when I say how long will it be in the air, what am I asking for? I'm asking for distance or I'm asking for time.
Time.
Okay, so they are giving me the, they're asking me to find the time. So this time is going to be unknown. And here, the 2 meters, those are units of what? Velocity, acceleration, position, time. What units are those? Meters. What is it? Is it velocity, acceleration, position or displacement or
Position. Displacement.
okay, displacement, position. But as I told you already in falling objects, the displacement is going to be written as delta. Why? Because the objects are moving vertically. So in this case, the change in position is going to be in the y-axis. Now, the question, how long will it be in the air before it strikes the floor, it also includes one more given, and it's this one. Strikes the floor. That part of the sentence is telling me that at the end, that volleyball is going to reach the floor. Okay, so what is going to be the position at the floor? I mean, vertical position. Where is the ball?
0.
It's zero, exactly. So initially, my volleyball was at 2 meters above the ground, but at the end, the problem says that it strikes the floor. So that is going to be my final position is going to be 0 meters. Okay, so I have everything I need to calculate what I need. Okay, now I need to find the time. The equation that has the time is only the first one because the second one doesn't have a time, as you can see. So what should I do? If I need to find the time, I need to isolate for the time. So I need to isolate for the time in the first place. That is going to be my first step. Because the time is not given, I need to find it. So I need to find the unknown. In this case, I'm looking for delta t. So, because delta t is only included in the first equation, that is the equation that I will use to find the time. So, the equation is final velocity equals initial velocity plus gravity time. Do I have the final velocity? Do I have the final velocity?
Yes.
No, I don't. I have the initial one. This one is initial velocity. Okay? So I don't have the final velocity. I know the ball is going to hit the ground, but I want to see how much is going to be my final velocity before it strikes the floor. So I don't know what the final velocity is. So I cannot find the time without knowing the final velocity. I do know the initial velocity, that is 6 meters per second. I do know gravity, because even though if it's not mentioned, I know that if it's happening on Earth, it's going to be negative 9.81 meters per second squared. And also, I don't know the time. So I cannot find the time because I don't know the final velocity. So what I need to do is I need to find the final velocity by using the equation that I have here. Now, as you can see, the change in the position is not given in the problem. They gave me the initial position of the ball and the final position of the ball. Okay? So, you realize with here that we cannot really isolate for the time. So what do we need to do? We need to actually find the final velocity. So, final velocity squared is equal to initial velocity squared plus 2 times gravity change in the position, in the vertical position. Okay? We don't know this, but we know how to get it. Okay? How? Because delta y is equal to final minus initial. That is a formula that I gave you since we were using average velocity. Okay? What is delta x? Final minus initial. What is delta y? Final minus initial. So what is my final position? According to the data that we have, the final position is the ground. And in the ground, we have 0 meters. This minus is from the formula. And my initial position says that the volleyball starts is telling me the initial, okay, from 2 meters above the floor. So 2 meters above is going to give me this. So my change in the vertical position is 0 minus 2, which gives me negative 2 meters. So with this, now I'm going to replace it in the formula, okay? Now I know delta y. I know my initial velocity, that is 6. I know my gravity, and now I know delta y. So I can easily get the final velocity. But because it's raised to the second power, we need to get a square root at the end. So we say initial velocity squared, 6 meters per second, raised to the second power plus 2. Gravity, that is negative 9.81 meters per second squared. Even if it's not given, it's mandatory that you guys memorize that gravity is negative 9.81 meters per second squared. And in the last part, we have the change in the vertical position that we obtained. It was negative 2 meters. So this part, 6 meters per second squared, is going to give you 36 meters squared per second squared. And here, how much is 2 times negative 9.81 times negative 2? How much is that? You can write it in the chat.
39.24.
39, sorry, 39.34. I'm multiplying meters with meters, so it's going to give me meters squared per second squared. And the negative and negative is going to make it positive, okay? That's why here we have a positive. So we add the two values, 39 plus 36, and I have final velocity squared equals to 75 8.24 meters squared per second squared. I have my velocity, my final velocity squared, but I don't need that. I need my final velocity. So I need to get a square root in the two sides of the formula. Now my square root and the power of 2 is being cancelled. And how much is the square root of the answer?
8.67.
Okay, 8.67 meters per second. Now here we need to be very careful, and I need that you guys listen. Okay, remember that a square root can give you two answers, plus or minus. Okay, let's analyze the exercise. Let's analyze this exercise. It says Jason hits a volleyball so that it moves with an initial velocity of 6 straight upward. So the ball, initially this ball is moving upward with a velocity of 6 meters per second. Okay? If the volleyball, okay, we know that this volleyball is at an initial position of 2 meters per second. Meters, sorry. How long will it be in the air? Okay, so if it hits the ball, this ball is going to move straight upward, but then it's going to return. When the ball is returning, the velocity can no longer be positive, because if you say that the velocity is positive, you are saying that the ball is going upward. But at this point, before the volleyball strikes the floor, the volleyball is coming down. Okay? So my velocity when it's going up is going to be positive, but when it's coming down, it's going to be a negative velocity. So even though here we are always going to obtain a positive value, we're going to write the direction of the velocity, which in this case is negative. Why? Because the volleyball, before it strikes the floor, it is going downward. Okay, so we choose the negative velocity, the negative result, because the volleyball is going downward. Okay, so in this part you need to be very careful, because if you forget, your time is going to be negative, and you know that the time cannot be negative. So you need to be very careful in this part. The topic is very easy, but still, just remember, if the object is going down, it's going to have a negative sign. Though this exercise is not asking me to find final velocity, it's asking me to find the time. But I cannot find the time if I don't have the final velocity. Okay? So, what do I need to do? I need to isolate for the time. And if I isolate this, I'm going to need the final velocity. So in the third step, I have my main equation, and now I'm going to do the isolation. If you see, I wrote that the first step is the isolation, okay? But when I was about to do it, I noticed that I couldn't actually get it. So I stopped. Now I have my final velocity. So that means that I can isolate, okay? I know my final velocity, that means that I can isolate. So the first thing I do is I'm going to move the initial velocity. Initial velocity here is adding, okay? So when you move it to the other side, it's going to be subtracting. So my formula has changed to final velocity minus initial velocity equals to gravity time. Okay? Because if I remove this term, it's gonna leave me just gravity and time alone. Okay? So what I did was just changing the position of them. Now, what is gravity doing to the time?
Multiplying.
It's multiplying. So to isolate it, if it's multiplying, you're gonna send it to the other side of the equation, and you're going to send it to divide. Okay? So you will have whatever you had here initially, that was final minus initial velocity, and you're going to divide by the gravity. This is gonna give me the equation for time. That is the isolation process, but this is the equation that we are going to be using to find the time. So I'm going to recommend that you memorize this isolation. Okay, if you don't want to isolate, if you're not good at isolations, at least memorize the formula. But if you tell me, no, miss, I'm not good at isolation either, okay, well, that's a big problem that you have. Anyway, I have the two velocities and I have gravity because that is a given. So all I need to do is replace, okay, all I need to do is replacement, okay. Final velocity. The final velocity, we know that is negative 8.67 meters per second, okay. So I'm going to make substitution of the givens. I'm gonna work here. So I know that is negative 8.67 meters per second minus my initial velocity. Initial velocity in this problem is 6 meters per second positive, okay? So I'm just going to write it minus 6 meters per second. All this divided by gravity. As you know, because I already told you many times, gravity is negative 9.81 meters per second squared. This division is going to give me what I need to find, that is the time. Now, I recommend to do this step by step. First, we better do this subtraction. How much is this? You can write the answer in the chat. Remember, that's your way to participate if you don't want to write to turn the microphone on. So how much is this? Remember, I told you many times that you have to do it step by step, okay? Negative 8.67 minus 6 is going to give you a negative number. How much is that?
Negative 14.67.
Negative 14.67. All this divided by the gravity, that is negative 9.81 meters per second squared. Now here you can notice that we can get rid of the negatives. They're going to be canceled. Then meters with meters, they're also going to be canceled out. And seconds with one of the seconds from the bottom are going to be canceled out as well. So how much do we get when we divide 1467 by 8.81?
1.5.
Uh-huh. Well, 1.495 is going to give you 1.5. So 1.5 or 50 if you prefer seconds is going to be the time. So when the problem says, how long will it be in the air before it strikes the floor, we say, okay, the volleyball will be in the air for 1.5 seconds. Okay, so you can write the answer as a sentence if you prefer. So guys, even though free fall is a very simple topic, you need to be aware that a wrong symbol is going to give you a wrong answer. Imagine, just imagine that here in the final velocity, you put the positive value of the final velocity, okay? So what is going to happen if you do that? The time is going to be different. First of all, the time is going to be different. And also the time is going to give you a negative time. And as I already told you many times, you cannot have a negative time because we cannot go back in time. So you cannot go and fix what you did wrong yesterday. In that case, yes, it is necessary to do rounding because the number that we have after the 49 is 5. So the rule says that if the third decimal place is occupied by 5 or a number greater than 5, then yes, we have to do the rounding. Now, is your answer wrong because you forgot to round? Then no, of course it's not wrong, okay? But that just tells me that you have problems at rounding, which is no good neither. Okay, so that's why we do the rounding. So what you can do is this is the formula to find final velocity, and this is the formula to find the time. Okay, already isolated for the time. So anytime I ask you to find the time and you have the two velocities, you know that you can get the time easily. Okay, so it's quite simple. It's nice, and I don't know if you have any other doubt. It is important that you write the good symbols. I repeat, because it says that the volleyball starts from 2 meters above the floor, because it says above, we're going to put a positive symbol. And because it says initial velocity, 6 meters per second, straight upward, upward is telling you a positive symbol for velocity as well. Now imagine that the problem says if the volleyball starts from 2 meters below the ground, okay, then you have to write a negative symbol for it. So every word problem is going to have a different approach. So I'm going to upload in Classroom, I'm going to upload another video where I solve 2 more problems about free fall, so you can study from those exercises as well. Okay, and next week is vacations, I know, but the week after, we're gonna do more problems of this topic. Efrain, tell me.
Will you upload this work?
Yes. It, what you mean this work? You mean the whiteboard?
Yeah, the whiteboard.
Yes, I will, and also the video, okay? Because I recorded the meeting. Well, guys, I'm gonna leave it here. Enjoy. If you have any doubt about your final score, let me know. I will be having the full platform probably by Monday, okay? The 9 weeks. And if you didn't do yesterday's quiz, so your final score is gonna be well, it's not gonna be ready, okay? But we're gonna fix it after holidays, okay? So enjoy.